Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on how to find the sample size to estimate the mean. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video. When we constructed confidence intervals, we often had samples given to us to create those intervals. In the real-world situations that we will run across, we would be expected to go out and get those samples ourselves. How large a sample should I take would be an important first question to ask yourself. If we could measure every single part, person, or item in the set, we would find the population mean. Since that is usually not feasible, we take a sample, and the next thing we want to know is how large is large enough to be as accurate as we are required to be. How large a sample should I take if I want to know the mean within a plus or minus E? So how large a sample is in our sample size? How many items should I have in my sample size? And E is our margin of error. How close to the mean do we want to be? So we want to be within so many units of the mean. And by the units, I mean so many miles if we're measuring in miles, within plus or minus E pounds if our sample is measured in pounds, centimeters if we're measuring in centimeters, within so many units, whatever that unit may be. Well, how will we know when we're being asked to find a sample size versus being asked to construct a confidence interval? Look at the question and read it carefully. Notice the question here is how large a sample, and then the question mark. We are looking for the N. For teachers here at Walter State, you are normally given your formulas. Please check with your instructor to verify this. How will you recognize your formula? Well, since we are looking for N, your formula will be solved for N. Since we want to find the sample size, it will also contain the E, which is our margin of error. And since our formula for confidence interval uses them, it will also contain your Z sub alpha divided by 2 and the standard deviation. Here are some important things to remember about this formula. We will round up to the nearest whole number, and we'll discuss this a little bit more as we get into the example, but it will be rounding up to the next nearest whole number. We will need to know the population standard deviation, or sigma, or have a reasonable estimate. And by a reasonable estimate, we will use an educated guess by experts in the field, a prior study or pilot study. We will use sigma from a similar group that's been studied, or we can estimate the range of values and use the standard deviation as the range divided by 4. I will now work this example to show you how the formula works. A poultry farm is studying the egg-laying capabilities of a certain type of hen. How many eggs must be sampled to be 95% confident of the mean egg weight to within 0.40 grams? In a similar breed of chickens, the standard deviation is approximately 1.77 grams. After reading the problem, you will need to determine what the question is asking us to do. In this problem, there's a question mark. So what does that sentence say? That sentence says, how many eggs? So if it asks how many eggs, that means it wants to know the sample size, as opposed to previous problems when it asks us to construct a confidence interval. This one says how many, and how many is asking for n, the number of our sample, and that would answer the question we're looking for. Therefore, we're looking for the sample size, and here is our formula. Next, we want to determine the variables in our formula. And when we are working with these problems and others in this section, remember there's a little bit of the plug and chug mentality. We find our formula, write it down, find your variables, and then plug them in and chug out the answer. Yes, there's usually a little bit more to it than that, but it starts with the formula and plugging in the right numbers and getting a value for that formula. Again, what I call the plug and chug. So we'll start with the Z alpha divided by 2. So we're dealing with 95% confident. So if we're 95% confident, our alpha is 100% minus 95%, which is 5%, which is 0.05. Divide that by 2, which is 0.025, and looking up the Z for 0.025, and that's a Z, so we go all the way down to the bottom of our T student distribution table, and that gives us 1.960. Next, we want to find our standard deviation, our sigma, and it's approximately 1.77 grams. Next is our E, and that's how close we want to be to the mean weight. And we want to be within 0.40 grams. The within is a nice key word to look for. It won't be the only one used, but it is a often used word. So our E is 0.40. So our Z at 1.960, our standard deviation or sigma at approximately 1.77, and our E of 0.40 are plugged into the formula. One of the most often things for students to forget is the square on the outside. Please do not forget that squared. And when you plug that in everywhere, and Ms. Borlaug went back through. When you plug all that back through, you get 75.2209. Now, that means we need to look at 75.2209 eggs. So if we rounded this to the nearest whole number, that would give us 75 eggs, which is not enough. We need 75.2 eggs. So since we cannot study half an egg or weigh half an egg and make it a legitimate part of our sample, a sample has to be a whole number, and therefore 75 is not enough. So the smallest sample size that would be enough would be 76. So when you get your sample size, you will round up to the next whole number, or round up to the nearest whole number, the next whole number up in size. And so that will go up to 76. That is the smallest whole number that is enough. So 75 would be going down to the nearest whole number, but we want to round up to the next number. So our answer would be 76. Here are some exercises for you to try. Remember, if you are doing these for quizzes, you must show your work to get credit. Thank you for watching, and I hope this was helpful.